Gaining insight from your content via NoSQL. Um, so I am Kyle Adams. I'm the America Support Team Lead. Um, connect with me through Twitter, LinkedIn, email. Talk to me after the presentation. Have drinks with me downstairs. All of the above. So I don't know if you guys caught the reference here, but it's a Carly Rae Jepsen song, and I apologize in advance for getting this stuck in anybody's head, but I just constantly hum this to myself, and it's a really bad song, but it's just one of those songs. So what I want to cover today is overview of the NoSQL universe, graph databases in general, and NoSQL in particular. Then I want to move to how we can integrate Alfresco and Neo4j, and a few example use cases that we can use with that integration. So let's start off and explain what exactly is content analytics. The most general description is applying business intelligence and analytics to ECM, but we shouldn't be confused because analytics is not the same as reporting. So what we really want to gain out of analytics is identifying trends, patterns, and correlations, and basically telling you, tell me what I don't know about the content that I'm storing in my repo. So that's analytics. So why are we using NoSQL? Can we do the same things in a relational database? Sure. But for today's world, there's a lot of demand on a few trends. There's a driving trend for data size. We create more content every year, and it exponentially grows. Second trend is the connectivity of data. So we start from flat documents in the early 90s, and in some far-fetched future, which probably shouldn't be that far, is the GGG, the global graph. So basically that's, all the data that's meaningful to you is really semantically connected and intertwined on the web. So the next driving trend is semi-structured information. Content is becoming more unique. You can no longer store information in 1970s style databases. Before, you could simply put everybody in a certain table, like a job title table for a support engineer, but you can blame Generation Y, myself included, because we want all of our information to be unique. I don't want to be called a support engineer, and you can't fit that into a job title table. I want to be, this awesome core repository developer, and it's difficult to express that in the same tables that we used to. So here's another view of performance curves with relational databases. I mean, we see that relational databases actually do quite well with tabular data, and the majority of the web applications today do quite well with tabular data as well. But when we move towards data structures such as social networks and the semantic web, we see performance fall off with relational databases. So now let's move to the different types of NoSQL stores. We have key value, column family, document databases, and graph databases, which is my corner of the universe for NoSQL. Albeit small, but I think very interesting and very powerful. So now we have key value stores. Key value stores are based on the Dynamo white paper. So basically Amazon created this database to support their checkout process. It had to be highly available, highly fault tolerant, and it had to always be up and never down. So the basic data model for key value stores is it's simply a hash map. So examples of that are Redis, React, and Voldemort. Strengths and weaknesses of key value stores. Simple data model. Again, it's just a hash map. Weaknesses, it's a hash map. I mean, it's simplistic and you can't store complex interconnected data. Next, we come to column family stores. Examples of this are Google's Big Table. They wrote a white paper called Distributed Storage Systems for Structured Data. It's basically a tuple of a key value where the key maps to a set of columns. So a KVVVVV store, basically. If you ever tried to program against these column family stores, it's sometimes quite complex to comprehend, so I tend to shy away from them. Examples of this are Cassandra, HBase, and Hypertable. A few of the strengths and weaknesses of column family stores. Data model supports semi-structured information. They're naturally indexed, horizontally scalable, just like key value stores. Another weakness is that it does not handle interconnected data very well. So you kind of starting to see a trend here with the interconnected data, and that's just because I'm biased against graph databases. So now we come to the more popular document databases. Everybody's pretty much heard of MongoDB, CouchDB, Lotus Notes. Anybody out here still using Lotus Notes? Please say no. But interestingly enough, Lotus Notes is actually one of the first document databases. So the data model is basically a collection of documents, and a document is a key value collection in itself. Great index support, and they do very well at scaling. So some of the strengths: simple but powerful data model, good scalability. Weaknesses, again, doesn't handle interconnected data well. Querying is limited to keys and indexes, and for large, queries, you have to basically use MapReduce for large queries. And now we come to graph databases. Data model, you have nodes with properties, named relationship, also with properties. Examples, Neo4j, which is my favorite, Sonus GraphDB, OrientDB, Infinite Graph, and a Lego Graph. So graph databases, strengths and weaknesses. Extremely powerful data model. It's the richest of all of the NoSQL types. Very performant when querying interconnected data. Easy to query. Weaknesses, it's terribly hard to shard. So basically, maps are mutable. So you have to basically manage, basically, if you shard based on domains, you have to manage the connectedness of whether or not you can connect to one shard to another on the application level. So if you're sharding and you have connections between the two shards, then it obviously results in poor performance if you have to go over the network. So of all the databases, including relational, we have a comparison of complexity versus size. Relational is way down at the bottom. Graph databases can handle the most complex data models, and key values are all the way on the right-hand side as far as size go. But that's not to say that graph databases can't handle 90% of your use cases. So I mean, if you think about Google and Amazon, those are use cases that you don't encounter very often. So typical use cases for graph databases are recommendation engines, business intelligence, web analytics, indexing your relational database. Some people consider Solr as a NoSQL store, and I think that's absolutely true. So maturity of the data models. NoSQL in general is still pretty young. Approximately 6 years. Relational is getting old there, about 42 years. But graph theory has been around for 200 plus years, and obviously that's kind of skewed, but I still like to hold true to that number. I mean, your bosses might argue that graph databases are immature and you can't bring them into the organization, but this mathematical theory has been along for a long time, and graph databases are based on that theory. So here's my homeboy, Leonhard Euler. He's the inventor of graph theory, circa 1736. He's a Swiss mathematician, and apparently the way that he's dressed, he's the original hipster. So I like this guy. Graph data model is very simple. We basically have nodes and relationships between the nodes. You can name the relationships. So basically, a person can be attending a particular event, and the event can be hosted in a particular city. And within that data model, you can add properties to both the nodes and the relationships. So we see that Kyle is attending DevCon that's hosted in San Jose. And here we come to Neo4j, finally the meat of the presentation. What exactly is Neo4j? It's currently the leading open source graph database. You can use it in embedded mode and also in a standalone server. It's ACID compliant. It's whiteboard friendly, which is the main reason why I decided to adopt Neo4j for my particular side project. I found myself spending a lot of time whiteboarding my domains, and it's just a particular preference of mine. And then I would spend a lot of time basically mapping that to a relational data model, normalizing it to the nth degree, and then deploying it into production, and then come to realize that it performs like dog shit. So I have to spend more time denormalizing that database, and before you know it, you've wasted a week of your time. So what's great about graph databases is that you can take what you've mapped on a whiteboard and apply it directly in your code, which is very good. And it's stable. Neo4j has been around since 2003, and it's been in 24/7 production since then. More reasons why I like Neo4j. It's highly performant for doing graph operations. On commodity hardware, such as my MacBook, you can do 1 million+ traversals per second. So now we come to, I guess, the size argument of why people think you shouldn't use Neo4j. But per instance, you can actually load 32 billion nodes and 64 billion properties, which is more than we can store in Alfresco today. So I think there's still a good argument to use Neo4j. So NoSQL stands for not only SQL. So how do we query this graph database? Some of you might know this comic already, but I have to give credit to the Basho React team for having a sense of humor, and a nerdy one at that. So how do I query the database? It's not a database. It's a key value store. Okay, it's not a database. How do I query it? You write a distributed MapReduce function in Erlang. Did you just tell me to go fuck myself? I believe I did, Bob. So the real answer is traversals. So traversal is basically how you move from node to node based on these relationships. So to better explain how traversals work, we'll look at a case study done by Neo Technology, which is the commercial backer of Neo4j. So they basically compared MySQL versus Neo4j in a social network scenario. So for this particular experiment, the first rule of Fight Club is never talk about Fight Club. But really, so the components of this experiment is we're going to run a friends of friend query. So basically, we're going to search for Kyle and his friends. And we're going to go to depth 5. So friends of friends of friends of friends. And each person will have an average of 50 friends. Again, this experiment is run on a commodity hardware i7 laptop with 8 GB RAM. So basically this laptop that I'm presenting from right here. I didn't run it, but it was the Neo Technology team. So the relational schema is pretty simple. You basically have a table for users and a table that stores foreign key and primary keys to describe the relationship between the users. And this is an example of the query. As you increase the depth, you add more inner joins, and you probably already know if you add more inner joins, performance degrades significantly. It's probably not the best way to retrieve this kind of information, but this is the way they executed this particular experiment. So the results we see from MySQL are at depth 2 and 3, MySQL performs reasonably well. But once you start to add inner joins at depth 4 and 5, we see extreme performance degradation. 10 seconds is okay, but within the click stream, users are going to start to complain. So now we come to the social graph model. It's your typical graph. There's not a whole lot to talk about this, but it's basically maps out friends of friends and relationships. So here's how you would traverse a Neo4j network through the traversal API. So basically, you see that we're going to traverse the type of relationship is friend of, and the direction is outgoing. You can set the depth with evaluators at depth number 2, 3, and 4, and 5. And you see that we're going to use a uniqueness of node underscore global. And that basically means I'm not going to visit the same node more than once for this particular graph. So the results for Neo4j for 1,000 users is pretty good. We see that there's a small increase in response time at each depth, but it's pretty manageable and it's extremely performant. And now we're going to bump up the number of users for the second round. So they moved from 1,000 users to 1 million, and as you can imagine, the MySQL performance is going to degrade significantly. So at depths 2 and 3, it performed reasonable for the amount of results returned. Sorry for the little text there. But 30 seconds at depth 3, at depth 5, it did not finish after an hour. So they basically killed the experiment at that point and said, it's not even worth recording the results for that particular depth. On the Neo4j side, we see a linear increase from about a tenth of a millisecond all the way up to 2 seconds. And I'm going to explain exactly why that is the case. So why is relational databases performance so horrible? So basically, to find all friends at depth 5, MySQL has to create a Cartesian product on the table that stores the relationships, the foreign keys in the user table. So that means it has to create the Cartesian product 5 times for that depth 5 query, and resulting in 50,000 at the power of 5 records returned, and only of which 1,000 are the results that we're looking for. So not very efficient for getting that type of data. As opposed, Neo4j simply will traverse through the nodes in the database until there are no nodes left. So more information on traversals. Graph data structures are localized. So basically, if you want to count, for this same experiment, I may ask you to count all the people around you, and you can do that reasonably efficiently. And if you add more people in the room, say right now we have 50, if we add 100 more, you'll still be able to count all the people around you in a reasonable amount of time. It may take a little bit more time because there are more people in the room, but you're still only counting the people around you. Alfresco and Neo4 integration. So basically, what I've done thus far is I've left Alfresco by itself, and I've taken the model that we used for Solar with eventual consistency. I did not want to install anything on the Alfresco side, and I decided to leverage CMS and web scripts to pull in data. So basically what I've done is I've pulled for documents and folders using CMS, and everything else I've used web scripts for. So people, workflows, auditing data, activities, and the like. And over on the on my custom application side, I've leveraged Spring Data to persist all of this to Neo4j. I'm also using Open NLP for natural language processing. So for content analytics, you don't want to store a lot of noise words. So this allows you to basically parse the text and only leave the words that you think are valuable. So for example, verbs and nouns. Neo4j and Alfresco use cases. So I haven't actually built this, but these are just examples to whet your appetite and to get you thinking on how you can use the two together. Retail analytics. So imagine we have ACME Mullet Group. They cater to a lot of customers, American mullets, mullets for musicians, and Euro mullets. And what we can do is we can leverage frameworks like Spring Social to ingest social content into Alfresco, whether it be Twitter, LinkedIn, or Facebook. And so, for instance, if I followed Peter Monks and he constantly tweets about mullets, he's actually influenced me about mullets. So from a marketing and retail standpoint, I'm more of a target to sell mullets to than anybody else. So rather than sending emails or coupons through snail mail, you can have a targeted market approach to say, Kyle is more likely to buy mullets than, blasting, a large target audience. Also, we have healthcare analytics, chronic disease management, and in particular, congestive heart failure. So chronic disease management and CHF in particular consist of the highest number of readmissions in the United States. 1 in 5 patients suffer from preventable readmissions, and those readmissions basically account for $17 billion in total medical care costs. So under the Patient Protection and Affordable Care Act, Centers for Medicare and Medicaid Services are actually starting to penalize providers for having high levels of readmissions. So through analytics and Neo4j, you can perform comparative analytics of patients and that have CHF and patients that have CHF within that family. So to identify indicators, you pull in a lot of data from the electronic medical record systems, but that only really accounts for 20% of the data. So that's kind of a scary thought that providers are making potential life-saving decisions on only 20% of the data. So what we really want to do is grab that extra 80% of unstructured data and pull it in and allow physicians and clinicians to make a more informed decision about your health. So what have I done so far with this side project? I've basically created the seamless integration, which was quite easy. I've done some web script integration with users and groups, but I also have to complete the workflow and auditing and activity side of things. But it's relatively easy to do with Spring's REST template. Basically, you provide a URL and it returns, you can tell it to return a JSON object or XML object, and you can map it to entities pretty easily. So that's what I'm using on a web script side. CMIS, it does quite well with documents and folders, but it doesn't give you all the information that you may need. So I use that as much as possible, and then I move to web scripts to get the more Alfresco-centric data that you can't get through CMIS. So what's next on my hit list? So more seamless integration, want to add the workflow and auditing data, as I said before. From a UI standpoint, I want to do graph visualization through libraries like D3 and charting as well. Also, I want to integrate activity. So basically, if there's a particular pattern that we provide, you can actually run a query in Neo4j to say, if this pattern exists in the graph, then create an activity workflow. So soon to be on GitHub. I'm going to do some cleanup and then I'll push it out to GitHub. But if you're interested in looking at the code, just let me know and I'll try and expedite that process. Also, credits to Neo Technology and Neo4j and Spring Data communities. A lot of the data that I pulled from this for this presentation comes from their documentation and also the Neo4j in Action book. All right, questions?
So I have a couple questions. So how does this effort align around this morning's keynote and the analytics kind of stuff that's over there too? Is this like
it's completely separate.
Okay.
So it's my own pet project. I'll certainly work with our engineering team if they want to, and I talk with these guys quite a bit. So if they want to align on this, I have no problem with that.
Then also another question would be, so what is your objective here? Is your objective here to create like a recommender type system? Is this just it's a pet project, but do you have a certain goal in mind related to being able to leverage the data on the other side to affect you?
Sure. Sure. So the holy grail for me is predictive analytics. So basically, we pull all this data into Neo4j, and as a business user, as a C-level person, how can I take all of this content that I already have in Alfresco and make critical business decisions based on that? I mean, it's not only compliance, it's not only records management. You have all this data in Alfresco, use it to drive your business and use it to drive revenue. You can certainly do that. Neo4j was just my preference. It was, the learning curve was much less than, the other stores. And, Neo4j has the benefit of relationships. So if I were to use MongoDB, you can store the same data structures, but you don't have the relationships between the data. So you would have to create that extra logic in your code to maintain those relationships. And
you just store them as extra tuples, right?
Right.
Basically store the relationships as an extra set of tuples.
Sure.
Something like in the Lego graph, the graph database that you can use the same graph that you have, but also the particle and
Absolutely. Any more questions? Nope.
I don't know, it's been like the John Newton thing, but it seems like it's getting to sort of like data warehousing where you start aggregating all this stuff together and then it gets out of date. So it seems like all this aggregating can run the same problem with data warehousing and stuff being out of date. And maybe for certain applications, stuff like that, maybe this will get the job done.
Sure, sure. And I guess the idea is that I want to run cron jobs and follow the eventual consistency model that we use for Solar. You don't need this data right away unless you're doing some extreme use case in retail analytics where you want to provide, the coupons for mullets within the checkout process or within the shopping experience itself. Anybody else? All right. Thanks, guys, for attending. Thanks for listening. I know I blazed through the slides, but I had 60 slides and I was a little bit worried. Thanks, guys.